So if we have two or more terms in the radical here, then, well, we'll see what happens. We've got to watch out for distribution. So we're going to use the same kind of things we do when we have a polynomial, same techniques that we use with polynomial expressions, all right? So remember, the radicals are just numbers, okay? They act very similar. So we're going to distribute here. We've got the square root of 2 times x. That's the square root of 2x. We like to put the x in front of the square root there. Square root of 2 times 4 is the square root of 8. Okay? And so we got x squared root of 2. We should simplify this square root of 8. Okay. Now, it's kind of a silly example in a way, because this probably should have just been a 2 all along, but anyways, there it is. Now we can't put that together. Yes, they're both square root of 2's, but x minus 2 is not a number we can deal with, so we just kind of leave it alone. Can't do much. Cube roots. All right, well, we got cube roots. Since it's all cube roots, notice everything is cube roots, so we multiply it. First term we're going to get is the cube root of x. What is it? X squared times x to the 4th. We add the exponents. That's x to the 6th. X squared times x is x to the 3rd, so the cube root of x to the 3rd. Okay? Can we simplify this? We can, because this is a multiple of this. This is x cubed squared. All right? Just basically dividing those powers. So 6 divided by 3 is 2. And here, the cube root of x, 3 divided by 3 is 1. This is going to be x to the 1st, or just x. Okay, so there's a start. What happens if we are multiplying with two binomials? Let's see what happens there. Multiplying with two binomials, we get some interesting things happening here. Now, we've got a 5 minus the square root of 3 squared. Now, be careful. Do not just apply this here. We can't just square the 5 and square the square root of 3. You can't do that. Why not? Because this is minus. It's not multiplied. Okay? So this is a subtraction. Okay? Totally different story. All right? If we had 5 times the square root of 3 squared, then that is 5 squared times the square root of 3 squared, which is 25 times 3, which is 75. That is a very different problem from what we have here. Do you see that? This is multiplication. This is subtraction. Okay? Don't square these. We have to write it out. 5 minus the square root of 3 times 5 minus the square root of 3. Okay? And now, remember what we got to do here? We got to distribute, or we got to FOIL. Hopefully you remember that from a previous algebra class. 5 times 5 is 25. 5 times the square root of 3 is, it's actually a negative square root of 3, so we've got to have a minus. 5 square root of 3. Okay, this is outside the square root, this is inside. So we just write it as 5 times the square root of 3. Square root of 3 times 5 is also 5 square root of 3. And that's minus because of this minus right there. Negative square root of 3 times negative square root of 3 is going to be positive the square root of 3 times 3, which is 9. And now we're just going to clean up a little bit. So 25. These we can simplify. They're like radicals. They're both the square root of 3, so we have negative 10 square root of 3. And the square root of 9 we know is 3. Now we can go a little bit further. We can combine like terms there. 25 plus 3 is 28. Minus 10 square root of 3. Can we combine the 28 minus 10? Nope. Don't do it. This is a square root of 3. This one does not. All right? There you have it. 28 minus 10 square root of 3. Leave it like that. That is simplified. Okay? All right. Similar idea, a little bit more going on here. We got 2 square root of 3 times the square root of 3. Well, this is 2 times the square root of 3 times the square root of 3. Well, we can multiply those to the square root of 9. We're multiplying now. 2 square root of 3 times the square root of 3. Now we're distributing here. 2 square root of 3 times negative 3 square root of 5. First of all, it's negative. 2 times 3 gives us 6. Square root of 3 times the square root of 5 gives us the square root of 15. All right. Now we're going to distribute the negative, or the square root of 5. Square root of 5 times the square root of 3 is the square root of 15. Now we're going to multiply square root of 5 times negative 3. So we've got negative 3. Square root of 5 times square root of 5 is square root of 25. Okay? Notice I'm not jumping too far. That's when mistakes happen. So if we go try to do them all in one step, you're going to make mistakes. Okay? All right. This is square root of 9 is 3. Now that's a step you might be able to skip and just write that as 6. That's okay. Let's combine these. We have negative 6 square root of 15 plus 1. There's an invisible 1 there. So negative 6 plus 1 is negative 5. And then the square root of 25 is 5. Okay. And once again, you probably could just go right to 15 with that, but okay. So I'm writing it out to be clear. That's 2 times 3 is 6. 3 times 5 is 15. And then almost there, 6 minus 15 is negative 9. And we got the minus 5 square root of 15. Is there any perfect square that goes into 15? No. You can't simplify it. You got to check, but we can't simplify it. Okay? So that's multiplying binomials. Here, again, we got to write it out and distribute. Binomial times a binomial. And here's an interesting one. Something really useful happens right here. Let's distribute. Square root of a times the square root of a. That's the square root of a squared. Square root of a times negative square root of b. Well, they're both under square roots, so that's our product rule. Square root of a times the square root of b, square root of ab, and it's negative because of that negative. Square root of b times the square root of a is the square root of ba or ab. And then the square root of b times negative square root of b would be negative square root, and b times b is b squared. Now, watch what happens. Square root of a squared is a. And what happens with these ones? Notice they're the same. They're going to cancel. Negative square root of ab, positive square root of ab, they just cancel. They make 0. And then last but not least, negative square root of b squared is negative b. And there it is. Notice no square roots. Interesting, huh? So this is a special situation because we have, these look a whole lot alike, but notice one is a plus, one is a minus. Okay, so we got a special situation, and that comes from one of our special products. So let's take a moment and look at these special products. This is going to come up a whole lot. Okay, we're in this chapter and in future chapters, okay? And hopefully you've seen this before. This is something you're going to want to memorize, okay? And we're going to use it a lot, so you'll memorize it by the end of our course here, all right? A plus b squared is a squared plus 2ab plus b squared. Where does that come from? Well, anytime you forget this, you can always work it out. A plus b squared means a plus b times a plus b. And if you distribute this out, a times a squared, a times b, ab, b times a, ab, and b times b, b squared. When you combine those, we get a squared plus 2ab plus b squared. Okay? So a plus b squared simplifies to this. Okay, if it's a minus b squared, well, we're going to get the same thing, but we're going to have this minus 2ab. Okay? So again, you want to memorize this. a minus b squared is going to be a squared minus 2ab plus b squared. So that is a binomial squared. Again, remember this is a binomial, two things added in parentheses. A difference of two squares, this is another thing that you've probably seen before. Okay, and this tells us that when we have a plus b times a minus b, we get a squared minus b squared. And you can convince yourself of that by just multiplying it out. A times a squared. A times negative b, negative ab. B times a, positive ab. And b times negative b squared. The middle terms cancel. And it leaves us with a squared minus b squared. Okay. So again, something to memorize. Okay. And it should just be a matter of understanding. Okay, more than memorizing. A plus b times a minus b is going to turn out to be a squared minus b squared. And this is a very useful relationship. We call these two binomials a plus b and a minus b. Those are called conjugates. Okay, they're going to show up in several different ways. So these are conjugates, same thing, but we got a plus and we got a minus. Okay, so let's see how we can use those. All right, so we've got these rules here. Well, here this is like a plus b squared. What does the rule tell us? The rule tells us we're going to have the first thing squared. Okay, now we could, by the way, we can multiply this out like we did up here. See, we did up here. We wrote it out and distributed. Okay, you can do that. But if we understand that this is always going to become the first thing squared, the last thing squared, and 2 times their product. Let's do that. So we have the first thing squared. That's the square root of 5 squared. Then we're going to have the last thing squared, the last addition there, okay? The last term, I should say, squared. And then in the middle, we've got 2 times their product. So there's going to be plus 2 times 3 times 5 is 15. A little cleanup tells us 5 plus 2 squared root of 15 plus, lost my plus there, 3. Or 8 plus 2 squared root of 15. Okay? How about this minus here? Okay, so this is like a minus b squared. Well, we're going to square the first thing. That's going to be 2 squared, square root of 3 squared. We're going to square the last thing. 3 squared and the square root of 5 squared. And then we're going to multiply, and it's going to be minus because this minus. So we're going to minus 2ab. So we're using this rule right here. So minus 2 times their product. Well, what's their product? 2 times 3 is 6. And then square root of 3 times square root of 5 is square root of 15. So a little bit more going on there. So we're going to be careful cleanup here. So 2 squared is 4. Square root of 3 squared is 3. And then we got 2 times 6 is 12. And then here we've got 3 squared, which is 9 times 5. Okay, and that's going to be 12 minus 12 squared root of 15 plus 45. Okay, so using the rule just kind of saves a step or two there. And 12 plus the 45 would be 57 minus 12 square root of 15. All right. Okay, one last one. This is the conjugates. What happens? Notice these look a whole lot alike, but one's plus and one's minus. So when we multiply them, we're going to have the first thing squared minus the second thing squared. The first number squared, well, what's the first number? It's the square root of 117 squared minus using what we discovered here, minus the second thing squared. So what do we have? We have square root of 116 squared. Well, those squares cancel those square roots. We just got 117 minus 116, and that's exactly 1. Okay? So with these powerful connections here, we get some crazy looking things that just become simple numbers like 1. All right, well, there you have it. Okay, there's how we multiply with binomials, and we multiply these special products. So with practice, you'll get these memorized. It'll come, all right? Make some flashcards if you want, but that's how we use our special products. Hope that helps. And with practice, it'll all make sense. So keep at it.